Introduction. Seesaws are such fun, Megha. What do you think? You are right, Vidhi. Going up and down a seesaw is such a great feeling. But it would be so much more fun if we could go up and down together. We will, but after 3 more cycles, as our speeds are not synchronized. Did you put one of your favorite mathematical concepts to find that out, Megha? That's right, Vidhi. I used the concept of HCF. In this lesson, you will learn about factors, multiples, HCF, LCM, and rules of divisibility. Properties of factors and multiples. Factors and multiples are numbers that possess specific properties. 1 multiplied by a number is the number itself. 1 into 2 is equal to 2. 1 into 3 is equal to 3. 1 into 4 is equal to 4. 1 into 5 is equal to 5. 1 divides every number exactly. Therefore, 1 is a factor of every number. Every number divides itself exactly. 2 divided by 2 is equal to 1. 3 divided by 3 is equal to 1. 4 divided by 4 is equal to 1. Therefore, a number is a factor of itself. The largest number that can divide a number exactly is itself. 2 is the largest number that can divide 2 exactly. Similarly, 3, 4, 5 and 6 are the largest numbers that can divide 3, 4, 5 and 6 respectively. Therefore, every number is the largest factor of itself. The factors of a number lie between 1 and the number itself. For example, let us look at the factors of 36. 1, 2, 3, 4, 6, 9, 12, 18 and 36 are the factors of 36. Therefore, the factors of a number are countable and hence finite. Product of a number multiplied by 1 is the number itself. For example, 2 into 1 is equal to 2. 3 into 1 is equal to 3. 4 into 1 is equal to 4. 5 into 1 is equal to 5. Therefore, every number is a multiple of itself. Products of all other numbers greater than 1 with the number are greater than the number itself. For example, 2 into 2 is equal to 4. 2 into 3 is equal to 6. 2 into 4 is equal to 8. Therefore, every number is the smallest multiple of itself. A new multiple of a number can be generated by multiplying it with a new number. For example, 9 into 1 is equal to 9. 9 into 2 is equal to 18. 9 into 3 is equal to 27. 9 into 4 is equal to 36 and so on. Therefore, multiples of a number are uncountable and hence infinite. Classification of numbers. Numbers can be classified as prime, composite, even and odd. Let us look at them one by one. Consider the number 7. Let us list out its factors. Let us look at some more numbers and their factors. What is common among these numbers? All these numbers have only 2 factors, 1 and the numbers themselves. Numbers that have exactly 2 factors, 1 and the numbers themselves, are known as prime numbers. 1 is a unique number. It has only 1 factor, 1 or the number itself. A Greek mathematician called Eratosthenes devised an easy method to locate the prime numbers between 1 and 100. Let us take a look at this method. We draw a table of 10 columns. In the first column, we list the numbers from 1 to 10. In the second column, the numbers from 11 to 20 and so on. Thus, in the last column, we list the numbers from 91 to 100. We cross out numbers that are not prime and circle those that are prime. 1 is not prime as it has only 1 factor. We draw a cross on it. 2 is prime as it has exactly 2 factors. We draw a circle around it. We draw a cross on all the multiples of 2. 3 is prime. We draw a circle around it. We draw a cross on all the multiples of 3. We proceed till we have drawn a cross or a circle around all the numbers from 1 and 100. This table is known as the sieve of Eratosthenes. The encircled numbers are prime numbers. There are 25 prime numbers between 1 and 100. 2 is the smallest prime number. All prime numbers are odd except 2. Twin prime numbers are 2 prime numbers whose difference is 2. Let us look at some more numbers and their factors. All these numbers have more than 2 factors. Numbers that have more than 2 factors are known as composite numbers. 1 is a unique number. It is neither prime nor composite. It has only one factor, 1, that is, the number itself. Let us consider the sieve of Eratosthenes. Crossed out numbers except 1 are composite numbers. There are 74 composite numbers between 1 and 100. Numbers that end with 2, 4, 6, 8 or 0 are called even numbers. All even numbers are divisible by 2 exactly. All even numbers are multiples of 2. All even numbers except 2 are composite numbers. Numbers that end with 1, 3, 5, 7 or 9 are called odd numbers. Odd numbers are not divisible by 2. All prime numbers except 2 are odd. Tests of divisibility. A number is said to be exactly divisible by another number if the division operation leaves no remainder. However, determining divisibility by actual division is time-consuming. Therefore, different tests have been designed to test divisibility of numbers by 2, 3, 4, 5, 6, 8, 9, 10 and 11. Let us look at them one by one. Consider some numbers: 40, 34, 78, 36, 32. Let us divide them by 2. 2 divides them all exactly, leaving no remainder. Consider some more numbers: 51, 45, 37, 79, 33. Let us divide them by 2. 2 does not divide them exactly. It leaves a remainder of 1 in all cases. It is clear that all even numbers, that is, numbers that end with 2, 4, 6, 8 or 0 are divisible by 2. Consider some numbers: 27, 36, 45, 54, 63. Let us divide them by 3 and 9. 3 and 9 divide them all exactly, leaving no remainder. Now let us sum up the digits of each number. What do you find? Each sum is divisible by 3 and 9. Consider some more numbers: 76, 23, 53, 79, 41. Let us divide them by 3 and 9. 3 and 9 do not divide them exactly. Sum up the digits of each number. What do you find? The sums are not divisible by 3 and 9. Therefore, we can say that if the sum of digits of a number is a multiple of 3, the number is divisible by 3. If the sum of digits of a number is a multiple of 9, the number is divisible by 9. Consider some numbers: 1248, 4336, 5424, 6456, 8768. Let us divide them by 4 and 8. 4 and 8 divide them all exactly, leaving no remainder. Consider the last 2 digits of the numbers: 48, 36, 24, 56, 68. The last 2 digits form numbers divisible by 4. Consider the last 3 digits of the numbers: 248, 336, 424, 456, 768. The last 3 digits form numbers divisible by 8. Therefore, we can say that if the last 2 digits of a number form a number which is divisible by 4, then the number is divisible by 4. If the last 3 digits of a number form a number which is divisible by 8, then the number is divisible by 8. Consider some numbers: 20, 35, 45, 50, 60. Let us divide them by 5. 5 divides them all exactly. Look at the last digits of the numbers. They are either 5 or 0. Consider these numbers: 90, 50, 60, 70, 40. Let us divide them by 10. 10 divides them all exactly. All the numbers divisible by 10 end with 0. Consider some more numbers: 46, 73, 89, 72, 51. They are not divisible either by 5 or by 10. None of them ends up with a 5 or a 0. Therefore, we can say that if the last digit of a number is either 5 or 0, the number is divisible by 5. If the last digit of a number is 0, the number is divisible by 10. Consider some numbers: 9383, 7986, 8382. Beginning from the right, sum up the digits at the odd and even places separately. The differences between the sums are either 0 or 11, both of which are divisible by 11. Consider some more numbers: 4231, 5466. The difference between the sums are 4 and 1, which are not divisible by 11. Consider the number 16. 8 divides 16 exactly. Two factors of 8, 2 and 4 also divide 16 exactly. Therefore, we can say that if a number divides another number exactly, then all its factors divide the number exactly as well. Consider the number 84. The co-prime numbers 6 and 7 divides 84 exactly. Their product 42 also divides 84 exactly. Therefore, if two co-prime numbers divide another number exactly, then their product divides the number exactly as well. Consider numbers 45 and 54. 9 divides both exactly. Consider the sum of 45 and 54, which is 99. 99 also divides 99 exactly. Therefore, it is true that if a number divides two numbers exactly, then it divides their sum exactly as well. Consider numbers 24 and 64. 8 divides both exactly. Consider the difference of 64 and 24, which is 40. 8 also divides 40 exactly. Therefore, if a number divides two numbers exactly, then it divides their differences exactly as well. Prime factorization. Factorization of a number is expressing a number as a product of its factors. Thus, expressing 48 as 12 into 4 is a factorization. Similarly, writing 6 as 3 into 2 is also factorization. But there is a difference between the two. The factors of 48 are composite, whereas the factors of 6 are prime. Expressing a number as a product of its prime factors is called prime factorization. Let us perform prime factorization on some numbers. 48 is equal to 12 into 4. 12 is 3 into 4. So 48 can be factorized as 3 into 4 into 4. 4 is 2 into 2. So 48 can be further factorized as 3 into 2 into 2 into 2 into 2. 48 is now expressed as a product of its prime factors. Prime factorization can also be expressed graphically with the help of a factor tree. Large numbers are prime factorized through repeated division by prime numbers till the quotient is itself a prime number. Let us prime factorize 430 by division method. First, we divide 430 by the prime factor 2. Next, we divide the quotient 215 by the prime factor by 5 to get the quotient 43. Since 43 is a prime factor, divide by 43 to get the quotient 1. Express 430 as a product of its prime factors. Uses of prime factorization. Prime factorization is put to two critical uses. They are to calculate HCF and LCM. LCM. Lowest common multiple or LCM is the smallest of all common multiples of two or more numbers. Let us identify the LCM of 10, 20 and 25. Multiples of 10 are 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 and so on. Multiples of 20 are 20, 40, 60, 80, 100, 120 and so on. Multiples of 25 are 25, 50, 75, 100, 125, 150 and so on. The first common multiple of 10, 20 and 25 is 100. Therefore, LCM of 10, 20 and 25 is 100. An easier method for computing LCM is the prime factorization method. Let us use the method to calculate the LCM of 16, 24 and 32. Prime factorization method involves dividing the three numbers by prime factors till the quotient is 1. Let us start with the smallest prime factor that divides at least one of the three numbers. 2 is the smallest prime number that divides 16, 24 and 32. Let us continue to divide the quotients by 2 4 more times till it is not possible to divide any quotient by 2. The next smallest prime factor that divides one of the quotients 1, 3 and 1 is 3. Multiply all the divisors 2, 2, 2, 2, 2 and 3. Therefore, LCM is equal to 2 into 2 into 2 into 2 into 2 into 3 is equal to 96. Let us look at a real-life situation where LCM is used. 3 bells ring at the intervals 10, 20 and 25 seconds. If their first ring is synchronized, when will the 3 bells ring together next? The time in which the 3 bells ring together must be a multiple of 10, 20 and 25. The time must also be the minimum time in which the synchronized ring will happen. The next time the 3 bells ring together is the LCM of 10, 20 and 25. LCM of 10, 20 and 25 is equal to 2 into 2 into 5 into 5 is equal to 100. The 3 bells will ring together after 100 seconds. Summary. Let us summarize what we have learnt. Factors of a number divide the number exactly. Co-prime numbers have 1 as their common factor. Factors of a number are limited. Multiples of a number are the products of the number with other numbers. Multiples of a number are unlimited. Prime numbers have only 2 factors. Composite numbers have more than 2 factors. One is neither prime nor composite. Expressing a number as a product of its prime factors is called prime factorization of the number. Highest common factor, or HCF, is the largest of all common factors of 2 or more numbers. Lowest common multiple, or LCM, is the smallest of all common multiples of 2 or more numbers.